So this is an update for a small model. After using this small model, it can better activate the multi-image reference capability of the 12.2 model. In fact, there are many models that refer to multiple images from the Wanxiang video. However, very few use the 2.2 version. Under the 2.2 system, we can reference it to fully tap into the model's potential. Moreover, its current status is that using this small model, the model's requirement for us is to merge several reference images into one and place them in the first frame of the channel video. From personal testing, we can directly assemble these elements and let the model complete the rest automatically. Some parts also work well. Then let's take a look at the workflow. I'm using RunningHub, the world's largest online rehabilitation AI training platform. This process will inevitably use up all our computing power, so it's still highly recommended to use online testing. The elements we choose from the reference image can be any elements. The training is unbiased and simply tests the model's own capabilities. If I had to be biased, it would definitely be the bias of Wan2.2 itself. Looking at the process, it's just the official basic solo video workflow for the Wan2.2 rehabilitation AI with no special features. The last article can only be done on our input items. I've tested the gain, and I don't recommend using acceleration with the high noise model at all. The low noise model isn't recommended either. The recommended resolution is 1280 by 720 or 720 by 1280 with a length of 81. This is the best result in this case. So if we want to test this scenario, it will consume all our computing power, and I've already decided on behalf of everyone that we need to load both high noise and low noise raw models from FFGO. The acceleration model will reduce the quality. What's the benefit of practicing the Vajra Buddha meditation? It will also reduce the quality of our generated content. Even in the image to video scenario, changing it to Painter I2V will still lower the quality of our generation. It seems very strict indeed. For each image we input, which is our hand frame, we can have one element per image. I haven't used the 720p aspect ratio yet. Using 720p would provide a clearer image. After decoding, we need to cut off several frames from the beginning of our generated video, because those initial frames are completely unrelated to the video content. Strongly correlated with our reference image, we haven't used some high dynamic acceleration models here. Actually, the problem isn't that big since our high noise model has run through so many steps, the dynamics aren't affected. What about the frame rate for our multi-image sequence? It's okay to use a collage style. Later, I'll add it to the workflow, navigate to RunningHub and click AI, or click the link in the introduction to register and you'll get 1200 HP. Logging in daily will also give you 100 points. The corresponding AI workflow for the video. All AI applications that can be started with one click have been deployed online and can run and test online. Here we directly see the creation of a fused image, which is then fed into the model to generate video from images, fully utilizing its capabilities. If the first image or another image is used as the background, isn't the main difference whether the background has been removed. Below the image, two elements have been added. A person and a sofa adjust their positions, then click continue to get our first merged image. After generating the fused image, we directly proceed to generate video from the image, and that's the final result. We could also achieve similar effects before by passing multiple elements through an image editing model first, then generating video from images, or using a series of image reference models like Phantom and Megarave. The dynamic quality of these later models isn't as high, but you can clearly see that these elements blend very well together. Using image editing models, we still need to extract elements from the image, such as the person, sofa, desk lamp, and background. There will inevitably be some loss in quality, and when it goes through our video processing workflow, it gets compressed again. At that point, the similarity between the original and the final result will drop significantly. I think this approach, which is integrated and relatively straightforward, is worth adopting. What if we just say, can't we avoid compression? The Crema model originally had an uncompressed version that didn't require decoding for generation. The memory usage level of this image generation model is almost comparable to that of a video model. Without compression, it's even more amazing for video models, and the memory usage is absolutely through the roof. On consumer-grade graphics cards, it's almost impossible to achieve this today. So is this image to video? It is and it isn't. If you directly input this image into the image to video model, there's a very low chance it will generate a full body completion. Although it's not a major breakthrough, I'll still share it with everyone. So most of the time, this channel shares open source models and projects, but closed source models are where RunningHub really shines. He brought down the prices of many popular models, like video. Some models like Collage and Wanxiang have specifications that are even lower than the officially announced prices. The more you use it, the more you'll realize that saving up over time really adds up.